Okay, so the last topic of this section, and I suppose our first sort of sophisticated counting technique is called the multiplication principle. Let me write that out. Multiplication principle. Right. Okay, and so what is the multiplication principle? Well, let me do an example, and let me do it sort of at longhand. Um, and show why it's really good for us to use the multiplication principle, but also suggest why it's true. So let's say I go to my favorite Indian restaurant. I'm getting some good Indian food, East Indian, of course, and I'm looking at three possible entrees. Just a sort of a plain old curry, or maybe a vindaloo, or finally, what I'll probably go for my favorite, which is Madras, I don't know. Now those are my possibilities for my entree. Now, typically I like to get this with chicken, or if I'm feeling a little bit fancy, I'll go with lamb. And finally, I'm going to choose some bread, and typically I'll go for some naan. But let's say that I'm you know thinking about mixing it up, so I might look for some. I might get roti, I might get paratha, or heck, I might get puri. Great. So I've got three possible entrees with two possible choices of meat and four different kinds of bread. I've underlined the first letter of each sort of thing except for paratha and puri. I'm going to underline the first two letters because that's how I'm going to represent each of these different choices. So get this down, and then I'm going to clear this. So what are my possibilities for a meal? Well, first I choose an entree, and I can choose the style of, say, curry that I want, so I could get just the plain curry, the vindaloo, or I could get what is probably my favorite, the madras. From there, I have two possible choices for each time. I can get chicken, or I can get lamb. If I get the vindaloo, I can get chicken or lamb vindaloo. If I get the madras, I could get the chicken or the lamb. Finally, from each of these guys, I have four possible choices for bread. I have the naan, the roti, the paratha, and the puri. And I'm not going to write that down for each of these guys. I'm just going to write down the fact that I've got four possible choices. Now, I could write down all of my possible choices by, for example, this first one I could write as C, C, N. The second one could be C, C, R. So that's uh, curry chicken with naan, curry chicken with roti, etc., all the way on down to the last possible choice following madras, lamb with uh, chicken curry, lamb madras with I suppose puri. But how many total possibilities is that? Well, here we have four possibilities, plus another four possibilities, plus another four possibilities, plus another four possibilities, plus another four, plus another four, and that all adds up to 24. Okay. Well, writing all this out is one way to do it, but another way of noticing how to do this is to notice that at each step, and let me sort of erase some of what I've written here. Get rid of possible meals. Let me get rid of this junk over here. And let me write some things down. My first choice, I had three choices. For my second choice, I had two choices, but there were 3 initial first choices, so I end up with 3 initial first choices times the 2 following choices I can make to get 6 total choices. 1, 2, 3, 4, 5, 6. Then finally, since I had 6 initial choices, and each of those 6 initial choices led to 4 more possible choices, and 6 times 4 is 24 final choices. So I had 3 initial choices, and then I had 6, let me just erase this and just explain what that was. But at the end of the day, what the deal is that the number of total meals, the number of total choices I can get, is 3 times 2 times 4 is 24. This is my first choice, 3 is my first choice, 2 is my second choice, 4 is my third choice, and altogether I get 24 choices. Great. So that's the multiplication principle. What it says is this. If, clear that, multiplication principle says that, the book says it a little bit differently, but let's say if I make, let's just do the simplest case. If I make 2 choices, C1 and C2, and if there are N1 and N2 possibilities for each choice, then the total number of outcomes is just the product of the 2 different numbers. I keep writing in instead of is. Outcomes is N1 times N2. Great. And this generalizes. Generally, if I have, say, k choices, where k is some number, and my choices are C1, C2, all the way through to CK, and I have N1, N2, NK choices for each of the guys. So N1 is the number of choices of C1, N2 is the number of choices for C2, etc. Then the total number of outcomes is N1 times N2 all the way up to NK. Okay, let's see some examples of this, and I've only got 7 minutes left, so I'm going to try to do this fairly quickly. So for example 1, let's look at passwords. Let's say you're putting together an 8-character password, and let's say the characters can be any digit or letter, and let's suppose only lowercase letters. So I'm making 8 choices here. I'm choosing my first character, my second character, my third character, all the way up to my 8th character. How many choices do I have? Well, each time I have 10 digits to choose from, or 26 letters, so that's 36 choices for my first character. My second character, it doesn't matter what my first character was, so I've got 36 choices there. My third character also has 36 choices all the way on down to my 8th character also has 36 choices. So the total number of possibilities, how many different passwords are there? It's going to be 8 times 8 times 8 all the way up to times 8. How many times? Excuse me. 36 times 36 times 36 all the way up to 36. It's multiplied against itself 8 times. What is 36 multiplied against itself 8 times? That's 36 to the 8th, which happens to be equal to, if you give me a second, I'll do let's carry the 1, and what do I get? I get, well, obviously the number is 2821199907456. Okay, that's a lot of passwords. That is 1,000 million billion, 2.8 trillion. That's a lot. But you would never be able to sit down and write out all those passwords. That's absurd. Okay. What's another possibility, or another example? Let's look at locker combinations. Now, typically a locker, with a typical sort of locker will have the not digits, numbers, numbers 1 through 40 on a padlock, and generally it'll be three, the locker combination will be 3 digits, and we generally assume that they don't repeat at all. So the first digit can be any of the 40, the second digit can't be the first digit, the third digit can't be the second digit. So what choices do I have? My first choice is going to be any digit. My second choice is going to be any digit that's not equal to the first choice. And my third choice is going to be any digit that's not equal to the first choice or the second choice. So how many possibilities do I have in each case? Well, for the first case, any number, well, I've got 40 different numbers to choose from, so great. In the second case, I could choose any of the 40 except for the one I already chose. So I've only got 39 choices, one fewer choice. For the third choice, I've got 2 fewer choices. It can't be the first digit we chose, it can't be the second digit we chose, it can be any of the other 38 guys. So the total number of combos here is going to be 40 times 39 times 38, and that number is, again, let me use the fantastic calculator that was built into my brain. That number is, it's not a whole lot, but it's more than enough to prevent somebody from sitting at the gym and trying every single possibility before you get done with your workout. It's 59,280 different possibilities. Although you can look up online ways to sort of get around the fact. You can listen to the lock and hear clicks when they spin around and stuff like that. So locks really aren't that safe. Anyways,